Today we're going to learn about angular and linear velocity. So it really helps to look at both of these equations side by side to understand how they differ from one another. As the name suggests, angular speed specifically has to do with how much the angle opens over a given period of time, whereas linear speed talks about the distance traveled by this object, so we're going to talk about arc length over a certain period of time. So these two formulas are actually related to one another using the central angle formula. So the central angle formula states that theta, or the central angle of a circle, is equal to the arc length divided by the radius. We can actually manipulate this formula to provide us with arc length given our central angle and our radius. So if I move radius over to the left, this formula becomes theta times r is equal to s. This relationship actually allows me to draw a connection between angular speed and linear speed. So if I multiply my angular speed by radius, that automatically gives me my linear speed. Remember that this statement right here, r times theta, is the same thing as saying arc length. And if I'm doing arc length divided by time, that is giving me my linear speed. It's also really important to understand conceptually the difference between angular and linear speed. So I want you to take a look at the two circles at the bottom of the screen. If you need to rewind and look at that again, go ahead and do so. But what I wanted you to notice is that as the central angle increases here, the distance traveled around the circumference of the circle increases. That's the difference between these two formulas. Angular speed is measuring how quickly this angle is becoming bigger and bigger over a period of time, whereas linear speed is measuring how far we've traveled over the circumference of the circle. And the only connection between both of these formulas is simply just the radius. If I multiply angular speed by the radius, I get linear speed. Now let's move on to an example of linear and angular speed. So here we have a bike tire that has a diameter of 12 inches and rotates at 470 revolutions per minute. So I'm going to take a quick second and highlight important information in the problem. Diameter, 12 inches, rotates at 470 revolutions per minute. So the first question is asking me to find angular speed in radians per minute. And quite honestly, when solving these problems, the best approach to take is using dimensional analysis. So I'm going to take information given in the problem and then use dimensional analysis to reach the answer I'm looking for. So far, I know that this tire is rotating at 470 revolutions per minute. If I want angular speed, I have to convert these revolutions into an angle. And we know every time a circle rotates one time, it opens 360 degrees. So let's add that conversion to our dimensional analysis. Now, one last thing I need to add is I have to get from degrees to radians. So remember, the conversion between degrees and radians is going to be pi over 180 degrees. So if I multiply these three fractions together, this takes me to my final answer. So going through dimensional analysis, I know revolutions cancel because there's one on the top and one on the bottom. And I also know my degree measurements are also going to cancel because there's one on the top and one on the bottom. So when I finish this off, I end up with 470 times 2 times pi over minutes. And if I multiply this out, this gives me 940 pi per minute. So what I need to understand here is that I've been given, or I have solved for my angular speed. And the next question is asking me for my linear speed. So we need to remember that if I have angular speed, all I need to do is multiply my angular speed by my radius to get my linear speed. So here they tricked us a little bit because they gave diameter. So we need to remember that diameter is always 2 times radius. So in this situation, my radius is 6 inches. So here I took the liberty of quickly doing the math. So I took my angular speed, I multiplied it by radius, and now I have my linear speed. But I'm not exactly finished with this problem because they're asking me for linear speed in feet per second. So here I have to do dimensional analysis again before I can get to my correct answer. So let's first start by going from inches to feet. So we know for every 1 foot, there are 12 inches. So I'm going to add that conversion. 1 foot is 12 inches. And then we also know in every minute, there's 60 seconds. 1 minute is 60 seconds. And now, if I multiply everything together, my final answer should be in feet per second. So I'm going to go ahead and do that. So using a calculator, I got 7.8 pi feet per second. There is one thing that we should quickly look over again. Whenever you're doing dimensional analysis and whenever you want to cancel units, you always want to make sure those units are diagonal of one another. So for instance, when I wanted to get rid of inches, I made sure inches was in the denominator of my next fraction. On the other hand, when I wanted to get rid of minutes, minutes was already in the denominator, so I wanted to make sure it was in the numerator of the next fraction. So again, if I walk through this, I see that inches cancels with inches, I see that minutes cancels with minutes, and this leaves me with feet in the numerator and seconds in the denominator, which is exactly what I want my final answer to be in. So I can take my answer one step further, and I can multiply 7.8 and pi together to give me a more clean answer. So when I do that, I end up with 24.6 feet per second as my final answer, which makes more sense because we don't really know what 7.8 pi is. So following this video is a handful of questions that are over angular and linear speed. Make sure you follow the different formulas. Always write out information that's important that's given to you in the question stem, and make sure you do dimensional analysis correctly.